All right, welcome everybody. Today we're going to continue with day 2 of graphing polynomials. Now, I'll remind you, our ultimate goal is for you to be able to sketch a polynomial graph, a highly accurate polynomial graph without a graphing utility. In the previous lesson, we reminded ourselves how to take x-intercepts and turn it into an equation, how to take an equation and find the roots or the x-intercepts. We talked about multiplicity, and then most importantly, we talked about what it meant for the graph. So given a graph, you were asked to write an equation. We're still not quite ready to create graphs from scratch, but today we're going to remind ourselves of other important things we need and then do a series of matching activities. Once you successfully complete this lesson and tonight's homework, you should be more than prepared for the next lesson where you're going to go ahead and finally be able to graph on your own. So what we have here to start us off is another reminder about end behavior. Now, this is the same description of end behavior from the previous lesson. Of course, it's what happens at the end, the left hand and the right hand. And of course, it is determined by the function's degree, whether it's odd or even, and the sign of the leading coefficient. Now, when it comes to finding end behavior, I know you've done it several times now, but for the matching activities we're about to go through and for when you actually graph on your own, it's very important that you understand the difference between finding a degree in standard form and finding a degree in factored form. So standard form is a little bit easier to determine the degree, but it's harder to find the x-intercepts, where factored form, it's much easier to find the x-intercepts, but a little harder to find the degree. So that's why it's important that you know both. So again, when it comes to standard form here in blue, the degree is the largest exponent only. Compare that to when something is in factored form, you have to find the degree by adding up all the x's, including their multiplicity. So before we even think again about graphing from scratch, or even before we even think about matching, let's make sure that we know how to find the degree from standard form and factored form. So again, first a little review. Everything in this first and second row both have a degree of 2, and everything in these last 2 rows have a degree of 3. But let's make sure we understand why that is using the rules for finding the degree. So again, here in the standard form, the degree is the largest exponent only, so 2. 2, 3, and 3. Anytime you see something in standard form, which means it's multiplied all the way out, the degree is only the largest one. Compare that to factored form, where it's written with all the different types of parentheses. You would find the degree by adding up all the x's, including any multiplicities. So this would be an x to the first, this would be an x to the first, that would give you an x squared, which is why the degree is 2. Similarly, in the next row, 1x and 1x, that makes a total of 2 x's, which is a squared. In the third one, you would count 1, 2, 3 x's, which again is why it's degree 3. And then in the last one, this x squared would count as 2. This would count as 1. 2 plus 1 is 3. So that's where you get the degree from. So again, very important that you can differentiate between something that's in degree standard form and finding the degree in factored form. Just a little note here while we're here about the sign of the leading coefficient. So the sign of the leading coefficient, regardless of whether it's in standard or factored form, you're always just going to look out front. So again, for the standard form row, nothing implies a positive, a negative, a positive, and a negative. Whereas if you're looking in factored form, out front, nothing implies a positive. Here's the negative. Nothing implies a positive, and then here's the negative. So you're always going to look out front for the leading coefficient, but you have to be very careful for the degree. So let's go ahead and just do some examples here to make sure that we can answer all the important information before, again, we even think about graphing. So for each of the polynomials, we're going to determine, is it standard form or factored form? Is the degree odd or even? What's the sign of the leading coefficient? And then we're ultimately going to determine the end behavior. So in number 1, because it's multiplied all the way out, that is standard form. In number 2, because you have all of those parentheses, factored form. 3, all the parentheses, factored form. Number 4, multiplied out, standard form. Number 5, 10x squared, that is standard form. There are no parentheses. Number 6, parentheses, is factored form. So then we have to make sure that we can find the degree based on the format. So standard form, it's going to be the largest one only. Something that's in factored form, you're going to add up all the x's, including the multiplicity. add up all the x's, including any multiplicity, and add up all the x's, including the multiplicity. So just to be sure, again, in terms of the degree, so number 1, largest exponent is 2. Number 2, add them all up. 1, 2, count the squared as 2 is a total of 4. In number 3, 3 plus 1 is a total of 5. Largest exponent for 4, largest exponent for 5, and then add up the x and the x squared for a total of 3. 2 is even, 4 is even, 5 is odd, 5 is odd, 2 is even, and 3 is odd. To find the sign of a leading coefficient, you're going to look out front. Remember that nothing out front implies that it's a positive. So taking a look here, in number 1, nothing out front, that's a positive, where number 2 is a negative, 3 is a positive, 4 is a negative, 5 is a positive, and 6 is a negative. So now try to see if you can remember your end behavior rules without looking at the table, although you can look up if you need to. So in number 1, even positive, that is up, up. Number 2, even negative, that is down, down. Then for number 3, odd positive, that would be down, up. Odd negative, that would be up, down. Even positive, that would be up, up. And then odd negative, that would be up, down. So again, these are the skills that have to be almost automatic for you to be able to both match and create graphs. So I'm going to call this next set of examples a little pause and try it. So if you're watching the video on your own, I suggest you pause, see if you can answer the next 4 questions, and then when you're done, start the video again. You'll see the answers. If you're watching this with your teacher, they'll pause it for you and give you a chance to try it. All right, so here are the answers to the pause and try it. So you have 3 of them that are in factored form, and then you have just one, number 9, which is in standard form. Hopefully you were able to correctly identify both the degree and the sign of the leading coefficient, and then we're able to correctly identify the end behavior. So if you have questions, you should ask your teacher. And again, even though you technically can use your notes to look up the information about end behavior, the more readily you're able to kind of memorize it, just the easier it's going to make your life once you actually start graphing. So again, as we start graphing and as we start matching, I first just want to remind you of something of a special case, and that's the constant function. So remember that the constant function would be y equals or f of x equals any constant. So y equals 6, y equals 10, y equals 0, y equals -5. A couple things I want to point out about the constant function. So first of all, a constant function is always just a horizontal line, as you can see over here on the right. Again, it could be y equals, f of x equals, doesn't matter. If you were to try to make a table of values, no matter what x you would plug in, you're always just going to get back whatever the constant is. So again, you have a nice flat horizontal line that goes on forever in both directions. Technically, the constant function has degree 0, but it doesn't exactly follow the rules for end behavior. So if you're talking about the sign of the leading coefficient, if your only choices for end behavior, if it's even, are up, up, or down, down, you're not really pointing up or down. You're always pointing left and right because of the fact that it's a horizontal line. What you can use to help you is if your constant is positive, you know you're always going to be above the x-axis. So y equals 1, 2, 3, 4, 5. Whereas if you have your constant function being negative, you always know that you're going to be below the x-axis. But technically, up, up, and down, down don't work for the constant function. Something else to point out, the constant function will have no zeros, meaning it will not cross the x-axis unless it happens to be the particular function of f of x equals 0. Think about every number but 0. If you had f of x equals 1, in this case it's 1.5, 3, 100, no matter what, if you were a horizontal line above the x-axis, you would never have any zeros. Same thing if you were below the x-axis, you would never have any zeros. The only way that you would have a 0 is if you were actually on the x-axis, which again would only occur if you happen to actually be f of x equals 0. So kind of important just to remind yourself of that special case of the constant. So if you see a function like that, it's actually the easiest one, so don't make it harder than it is. So now let's see if we can kind of apply some of these rules. Right now, we're trying to match the polynomial using the degree and the sign of the leading coefficient using its end behavior. Not only are we going to be using the end behavior, but we're also going to be just using the general shape of what we know about polynomial graphs so far. Something I want to point out is that all 8 of these equations are all in standard form. In a few minutes, we're going to see a mix of standard and factor form, but for now, they're all in standard form. So if we wanted to find the x-intercepts and use the multiplicity, we would have to factor and solve each one of those. I'm not asking you to do that right now. All I'm asking you to do is use the end behavior. So again, the fact that they're in standard form means that the degree of these polynomials for every one is just the largest exponent. So I'm going to go through and make sure I highlight the largest exponent. Now, again, all of these are in the correct order where the largest exponent is first. If you come across a problem where the largest exponent is not first, you're going to want to go ahead and first rewrite it. So here, now that we know what the degree is, so in number 1, we know that the degree is 1, which is odd, versus the degree 2, which is even, and then 2, even, 3, which is odd, 4 is even, and 5 is odd. Then we want to indicate whether it's a positive or a negative out front. So in number 1, it's a negative, positive, negative, positive, negative, negative, and then positive, positive. Now that we have that combination, we're going to go ahead and determine the end behavior. So in number 1, if you are odd negative, again, hopefully without looking, you're able to remember that that end behavior is up, down. Let me just write it on the other side so that we can see it a little more readily. So number 1 is up, down because it's odd negative. Number 2, even positive is up, up. Number 3, even negative, down, down. Odd positive is down, up. Odd negative is up, down. Number 6, even negative, that's down, down. Even positive is up, up. And then odd positive is down, up. So as we go to match these, we want to not only use the end behavior, but we want to use just what we know about the general shape. So for example, number 1, not only is the end behavior of number 1 up, down, but that is to the first power. So something that is to the first power, that's linear, which means we're looking for a line. We're looking for a line that starts facing up and ends facing down. And hopefully it would make sense that that would be over here. So this is graph number 1. Then for number 2, not only are we looking for a graph that is up, up, but that's an x squared, that's a quadratic. We spent a whole chapter on quadratics. So if you look at the 7 graphs that remain, I would hope that it's relatively easy for you to see that number 2 should match with G. Then for number 3, down, down, again, this is a quadratic. So if this is a quadratic that's facing down, that of course has to be a U, which means 3 matches with H. You should be very familiar with the graphs of 1, 2, and 3. And now we're bringing in the cubics, which we've been seeing now for a couple of days and throughout the chapter. So that might be a little bit easier. So the lower the degree is, the fewer turns that the graph has. You're going to be talking more and more about turns over the next couple of lessons. But a turn is basically if the graph is going in a certain direction, if it then changes to the other direction, that is called a turn. So this would be a turn and a turn and a turn. So what you're looking for here, again, the lower the degree, the fewer turns. So if you're looking at number 4 and you're looking at 2x to the third and you're looking for end behavior down, up, you're looking for a graph that has not a ton of turns and you're looking for it to cross the x-axis a total of 3 times. So if you look at the graphs in question, hopefully you would land on F being your choice. That has end behavior down, up. It has 1, 2 turns, and it crosses the x-axis exactly 3 times. For number 5, you're looking for a cubic polynomial that's up down. So again, one of the ones that has fewer turns, and you want it to cross the x-axis 3 times. If you count that bounce as a double, so you'd have a total of 3. That's why this would be number 5. Then for number 6, if you wanted to take a cubic and turn it into a quartic, you would have to do another turn. So if you have something to the fourth, it's either going to look like an M or a W, depending on whether it's facing up or down. So in number 6, you're looking for down, down. So if you are looking for down, down, and again, you're looking for it to cross the x-axis twice, if you count the bounce as 2, remember multiplicity, you know that this is graph 6. Then in number 7, you're looking for end behavior up, up. So if you're looking for end behavior up, up, I spy a multiplicity 1. I spy that flattening, which counts as 3. So that's how I know that this is 7. And then using process of elimination, again, if you wanted to take a quartic and turn it into a quintic, you would have to have another turn. You would have to cross the x-axis 1, 2, 3, 4, 5 times. And so for lots of reasons, this graph happens to be 8. All right, so at this point in time, you are ready to do a full-fledged matching activity on your own. So you'll notice that this is actually the homework. I'm going to do a couple of these with you just to make sure you understand what is being asked of you, and then you're going to have a chance either with the remaining class period or for homework tonight to go ahead and finish. Just to start, let's make sure we understand what we're being asked to do. So here on the first page, we have 15 different equations. These are all polynomial equations of varying degree, varying end behavior, and varying x-intercepts. You're going to be asked to match each of these 15 equations with each of these 15 graphs on the next page. Now, please be advised, each graph will be used exactly once. So you should not have any repeats. As you get to the harder ones, of course, you can use a little bit of process of elimination to help you as well. So I'm going to do, again, a random sampling of these with you. So I'm going to go ahead and start with number 1. Now, a note of caution before we get started. Technically speaking, could you just type this equation into your graphing calculator or Desmos, see the picture, and then pick the right graph? Honestly, yes. Should you do that? No, for a lot of reasons. Reason number 1, if you don't fill out all this information, it's very unlikely that your teacher is going to give you full credit for this assignment. Number 2, not only are we trying to prepare you for this year when it comes to these lessons, but we're also trying to prepare you for next year, in which case it's very likely you would not have access to a graphing calculator, at least not for a test or quiz. So my advice, why not try to do it this way, a little bit of a longer way, a little bit of a harder way, but it has a really, really big payoff. So what I want you to notice for the problems on this page is that sometimes you're given just standard form and sometimes you're given just factored form. So let's say that we actually compare 1 and 3. So in number 1, you are given standard form and then you are also given factored form, whereas in number 3, you're only given factored form. There's a couple of different reasons for that. Again, we want to make sure you understand the differences, but we also want to make sure you understand how the two forms are related. Just FYI, how do you go from factored form to standard form? You multiply or distribute. How do you go from standard form to factored form? You factor or do synthetic division, like we've been doing for the previous lessons. Because we already had a quiz on that, that's no longer what we're asking you to do. So we're going to give you the factored form, and then you just have to be able to use it. So here in number 1, if you're being asked to find the degree, you can either look at standard form and it's the biggest one, or you can look at factored form and add them all up. Either way, you should get a degree of exactly 3. For the sign of the leading coefficient, whether you look on standard or factored form, hopefully you would agree that it's positive. Because 3 is odd, odd positive is going to give you a down up end behavior. Then the roots and their multiplicity. The only way that you can find roots and multiplicity is from factored form only. You have to use factored form. So going from left to right, if you were to set everything equal to 0, the x squared would give you a value of 0, which would be a multiplicity 2. and then positive 3 with a multiplicity of 1. Hopefully you remember from yesterday's lesson, a multiplicity 1 means a cross, a multiplicity 2 means a bounce, and a multiplicity 3 means a flatten and then a crossing. So you are now going to look at the page of graphs. You are going to look at your 15 options, and you are going to try to find the one and only one graph that is a cubic, that has end behavior down, up, and you want it to hit the x-axis at 0 with a bounce and at 3 with a cross. So the winner is going to be over here at I. Let's kind of just zoom in. Hopefully you see the end behavior down, up. Here at 0, it's bouncing. And then here at 3, it's crossing. So graph I has to match with equation number 1. And you can either match it either way. You can write the number here next to the graph, or if you go back, you can go ahead and write the letter, which in this case would be I. I think it's probably better to write the letter here, but as long as you can match it, that's really the goal. So let's look at number 3. So number 3, again, notice it's factored form only. So if you have factored form only to find the degree, you would have to add up the exponents, including their multiplicity. So that would be an x squared and an x squared, which would have a degree of 4, which would be even. The sign of the leading coefficient would be negative. Even, negative, look it up if you have to, but again, sooner rather than later, you should kind of be memorizing those rules. To find the roots and their multiplicity, you're going to go ahead and set each value equal to 0. But remember, roots only come from x's. They don't come from numbers. So this -2, while it tells us about the end behavior, it does not give us any x's because it's just a -2. X plus 3 squared, that's going to give us a -3 m2. And then x plus 1 squared is going to give us a -1 m2. So as we go to look at our graphs, we're looking for a quartic. We're looking for the end behavior down, down, and we're looking at it to bounce at -3 and at -1. So again, if you have these graphs in front of you, which hopefully you do, you're going to go ahead and very carefully look at your options. If you're looking for this graph, hopefully you would agree. Oh, it's not even there. Sorry, you have to scroll down a little bit. So again, looking at all your options here, the answer is graph M. And let's make sure we understand why. So again, this is going to match up with number 3. Here's the end behavior, down, down, at -1 and -3. You have a bounce and a bounce, which means that has to be a multiplicity of 2. So going back, this is matching with M. And again, once you use it, you cannot use it anymore. That might be enough for you to solve the problems, but let's do 2 more just to be sure. So let's actually try number 9. So again, if you're looking at number 9, notice that again, it's giving you standard form on the left and factored form on the right. We want you to understand the relationship. So when it comes to the degree, you can either look at the largest one or add up all the x's, including multiplicity. Either way, you should get a degree of 4, which is even. If you go ahead and look out front, whether you look at standard or factored, it's positive. Even, positive, that's up, up. If you're trying to find roots and multiplicity, you have to look at factored form. When it comes to the x's, again, this 3 out front, it tells us about the end behavior, but it doesn't actually give us any roots. The x by itself, however, does give us a 0, m1, followed by a -1, m1, followed by a +1, m2. So you now have to go back to your graphs. You have to be looking, again, at all your different options here, except for the ones that you've already used. Obviously, you can't use those again. You have to go ahead and find the one and only one graph that has end behavior up, up. You want it to cross at 0 and -1, and you want it to bounce at 1. So take a look, see if you can kind of figure out which one it is on your own. I'm going to go ahead and help you by letting you know that it's D. So again, this is matching up with 9. And to make sure we understand, this is up, up. You're going across at 0, across at -1, and then here at +1, there's a bounce. So graph 9, or number 9, is going to match with graph D, And again, you should maybe even cross them out on the other page just so that you don't try to use them more than once. Let's do one final one together. And then again, you should hopefully be fine to do the rest on your own for homework. So taking a look at number 14, again, worth pointing out that it's a standard form on the left side with a factored form on the right side. So the degree from the left side is 4. From the right side, if you add up all the x's, still 4. 4 is still even. Out front, nothing is there, so you assume it's a positive. And even positive is up, up. To find the roots and the multiplicity, you have to look at factored form. That x cubed is going to give you a 0 multiplicity 3 and a 3 multiplicity 1. So remember that at a multiplicity 3, you're looking for that flattening and then a crossing. This one should be a little bit easier to match because of the fact that at 0, you have to have that weird flattening, and there probably aren't very many cases where that's happening. And hopefully you can clearly see that that is happening here at H. So here at H, you have your end behavior of up, up. Here at 0, you have that flattening and then crossing, whereas over here at 3, you just have that regular crossing. So this is going to go ahead and be graph 14. And then if we match the other way, 14, we're going to go ahead and indicate that this is H. So we have now done 4 of the 15 together, and you're going to go ahead for homework and finish the rest. Again, I strongly implore you not to take the shortcut, not to use a graphing utility, but genuinely try to see if you can fill in the information and then match. If you're able to do this with relatively little issue, then tomorrow when we full on graph from scratch, I think you're going to have no trouble at all. So thanks very much for tuning in, guys, and we will catch you next time.